Lesson 7.1, Angles of a Polygon. Essential question, what is the sum of the measures of the interior and exterior angles of a polygon? Let's take a look at a polygon. When we connect consecutive vertices, we call this a side. When we connect non-consecutive vertices, we call this a diagonal. It's important to take a look at the number of diagonals coming from one vertex. For this particular polygon, you can see I can draw 2 diagonals from this vertex B. We're not going to draw them all. Let's go and continue this pattern with these figures. I know that all of 3 of these angles of a triangle, the sum is 180 degrees. Over here I have a quadrilateral. I'm going to draw all the diagonals that I can from this vertex. And when I do that and get to this other vertex, I have created 2 triangles. So the sum of all the interior angles will be 2 times 180 because there are going to be 2 triangles. When I start here at this vertex and draw all the diagonals I can from this one vertex, it creates 3 triangles. So the sum of all the interior angles will be 3 times 180. Now, notice that this has 5 sides. Notice it has 3 triangles. 4 sides, 2 triangles. Hexagon. I'm going to draw all the diagonals I can from this one vertex. And when I do that, I'll be able to find the sum of all the angles inside the hexagon because that's going to be 4 times 180. And again, if you have 6 sides, you're going to have 4 triangles. Let's go to the theorem, and it says, this is called the Polygon Interior Angles Theorem. And it says if you want to find the sum of all the angles inside of a polygon, what you need to do is take the number of sides, subtract 2, and then times by 180. And that means that's because it's creating that many triangles. So this is the number of triangles created by all the diagonals from one vertex. Let's see how this formula is going to help us. We want to find the sum of the measures of the interior angles of this figure. Now this figure has 1, 2, 3, 4, 5, 6, 7, 8. It's an octagon, which is 8 sides. So I know the formula is the sum is equal to n minus 2 times 180. N minus 2 refers to the number of triangles. So there's going to be 6 triangles times 180. And 6 times 180 is 1,080. Okay, I'd like you to try it with this 11 gone. Stop the screencast and see if you can accomplish this. And here's the answer. I wrote down the formula, I substituted 11 in for n, and then multiplied it out. Okay, the sum of the measures of the interior angles of a convex polygon is 900. This is kind of a backwards problem. So they're not giving us the sides, they're giving us the sum. So here's the formula again, but this time I'm going to put 900 here as the answer. And then I have n minus 2 times 180. Now what I'm going to do is I'm going to divide both sides by 180. So I'm going to divide this side by 180 and this side by 180, and I'm going to get 5 is equal to n minus 2. And then I'm going to add 2 to both sides, so n is equal to 7. So a figure that has 900 degrees as the sum of all the interior angles is a heptagon, or a 7-sided figure. Sometimes we call it a septagon as well. The sum of the measures of the interior angles of a quad is 360. And that's, you know, when we have a quad, we know that it's going to, from one vertex, it's going to create 2 triangles. So 2 times 180 is 360. Let's use this to do this problem. I want to find the missing angle. So I know that all 4 angles have to add up to 360, and then I just do my algebra and find that x is equal to 72. Your turn. Go ahead and stop the screencast and see what you can do. Here are the answers. Okay, notice I went ahead and I substituted the answer and then I used algebra to solve, and I found that this was a decagon. Now the measures of the interior angles, I know that I have 4 angles. They add up to 360 because that's a quad. And when I did my algebra, I found x was 22.5, but they wanted me to find all the angles, so I substituted 22.5 in for x for all the other measures. Equilateral polygons means all sides are congruent. Equiangular polygon means all the angles are congruent. And now I'm going to introduce a very special word, and that's called regular. And regular polygon means both equilateral and equiangular. It has a very pleasing shape like this. Okay, is this polygon regular? And the answer is no. And the reason why is because it is not equiangular. If it were equiangular, all these angles would add up to 90, and it doesn't. We want to find the measures of angle C and angle E. So I know this is a pentagon. I know when I use the formula, I'm going to get 540. So I'm going to take all 5 of the angles. 2 of them I don't know, so I'm going to call them x and x. And then I do the algebra, and I find both of those will be 135. Okay, it's your turn now. Stop the screencast and try. And here are the answers. Let's take a look at all these exterior angles. Angle 1, 2, 3, 4, and 5. They're all on the outside of the polygon. If I were to take all these angles and pull them out and try to pull them together, they would add up to 360 degrees. So this is supposed to help you understand the next theorem. The next theorem says no matter how many sides a figure has, all of the exterior angles, the sum of the exterior angles, is always going to be 360 degrees. All right, let's take a look at trying to figure out what x is. There are 4 angles, 4 exterior angles, so I add them all up, and I know the answer is always the same number, 360. So again, I use algebra, and I find that the missing exterior angle is 68. Let's take a look at this problem. Here's a trampoline that's a dodecagon, which means that it has 12 sides. I want to find the measure of each interior angle. So I'm going to find the sum of all the interior angles, and then once I do that, every interior angle is the same, so I'm going to divide it by 12, and so I'm going to get 150 degrees as my answer. Now, to find the measure of each exterior angle, I know the sum is 360. I take 360 and divide by the number of exterior angles, which is 12, and I get 30. I want you to notice that 150 and 30 are a linear pair. They add up to 180. Now, those of you who want some shortcuts and do things a little bit more efficiently, then when you do this problem, don't do the interior angle first. Do the exterior angle first because it's the easier formula. So we take 360 divided by 12 and get the 30 degrees first. Once you get the 30 degrees, you know that the interior angle has to be the supplement because they are a linear pair. And take a look at this picture. You can see 30 degrees and 150 degrees do indeed make a straight line. Okay, your turn. Stop the screencast and try this problem. And here is the answer.